Okay, now these are still series. So we're going to do some combining with power series. And you can combine with power series exactly the same way. So you add or subtract. You can multiply by a constant. Anything that we do with our series that we've done previously, we can still do. All right. But I'm going to give you this one to begin with. So if I have the series of 1 over 1 minus x, all right? Right now I'm just telling you, if you have this, it's called the geometric series, but if you have this fraction, if you turn this into a series, you will get, k is going from 0 to infinity of x to the k, which is 1 plus x squared plus x cubed and more of that for all of x's that are less than 1. Now, spoiler alert, this is called the geometric series, so I'm going to write this down. Next section, we're going to prove this. All right, so next section, we're going to prove this, but for now, we're just accepting it. Oh, okay, thanks. Oh, that's awesome. Ooh, great information, right? Okay, so this is equivalent to this series, which is this polynomial, this is the interval of convergence. Right now, we're just accepting that. All right, now this is what we're charged with. For given this piece of information, I want to find the power series and interval of convergence. Of these. Now we're going to do some examples. Here's our first one. I have x to the 5th over 1 minus x. Our goal with this is to say what is the relationship between this and this. And you can see here that I could break this up to be x to the 5th times 1 over 1 minus x. All right? So we just said if you have a power series, you can multiply stuff together. You can add or subtract. Any of that kind of stuff is happening. All right? So my geometric series here, if I know I have this series and I have this x to the 5th times this piece right here, this 1 over x piece can be replaced with this series notation. So what we actually have is my series going from 0 to infinity of x to the 5th here times this x to the k. So my x to the 5th, because that's what's multiplied by, this can be represented in this series format by this x to the k. So if these two things are multiplied, then these two things are multiplied in my series. And anytime you have like bases, I'm going to write k plus 5. Anytime you have like bases, then you add those exponents. All right, so the same thing is happening here. If I multiply over here by this is my interval. If that is my interval of convergence, so if I multiply that x to the 5th, I'm not changing anything there. My interval of convergence is still, the absolute value here is less than 1. So we're really just using the concept of how do I put these two things together and I can still pull that off and make that happen. All right? Because my r here is still that x that I have, that base, that r, that. So this is a geometric series, right? Oops. This is my oh, for crying out loud in a bucket. I'll try to hit that. This is my r value. And so then we're still good to go. All right. Let's do this thing. going to make this to where you can see both of them. B is 1 over 1 minus 2x. Close, right? The biggest difference between these two is the fact that I have this 2 in there. So you could write it as 1 over 1 minus, and I'm going to put this 2x in parentheses because that 2x is that input value. So if these are multiplied, so I multiply. This is an input, so then I input. You see that? Okay, so I input that value. So I've got this 2x to the k. You have to put parentheses around there. Are these equivalent? No. The one on the right, the only thing that's going to the exponent here is this x, right? No. This whole thing is that input. The whole thing has to go to that k value, so you have to put both of them in there. Okay, good. Now I'm going to lose this because I don't want you to get confused when you look back at your notes. Alrighty. Now my interval of convergence, however, in this instance, is I've got this input of 2x that has to be less than 1. So I've got -1 is less than that 2x. So -1/2 is my interval of convergence. All right. So I'm going from -1/2 to 1/2. And that is my interval of convergence. Or you could write it as the absolute value of x is less than 1/2. I'm okay if you write it like that also. All right. Okay. Now, what if I have something like this? Let's do one more here. Yeah, we've got room. Here's C. I have 1 over 1 plus x squared. It's another input. Good. But what's my input? Yes. Do you see that? Let me bring this back up from the beginning. My formula is 1 minus x. So I still have to have this 1 minus, but because this is a plus sign, then I have to have minus a negative there. And I've got my x squared. Good. Okay, now let me make it big again so you can actually see it. So this tells me that if that is my input, I'm going from 0 to infinity now of this negative x squared to the k. Now here's your tip. Anytime you have a negative inside this symbol, you want to pull that out to make it look like an alternating series. So this is actually my series from 0 to infinity of -1 to the k and x to the 2k. Because power to a power you multiply, and I'm taking this -1 out with that k. So it looks more like that alternating series. All right. Okay. There it is. My interval of convergence. I now have my input here of negative x squared has to be less than 1. Well, whenever you take that absolute value there and you've got that square, the absolute value and the square, all of that thing is going to happen, and I'd still have that x is less than 1. Do you see that? The absolute value takes care of this. This is squared. It's already positive, so whatever it is that you get, you're still going to be less than 1 that you have. So my interval of convergence is the same. All right, the big deal here on these is you're just looking, I'm giving you this series. This next section, we're going to prove why all this stuff is true. But for now, I'm giving you this series, and you're just manipulating it either by multiplying input and input, however that input happens. All right? Okay, good. You guys got